Hi, and welcome to day 22 of Advent of Code and me trying to uh, solve the problem and stream my solutions in Go. Actually did look at the problem before today, and from what I can tell, it seemed, at least the first part seems quite manageable. We will see how we get along. I did tweet out earlier today that I actually, if you've been there, I struggled a bit with day 20, and I revisited that last night and ended up actually at least solving the first part. So maybe if I'm up to it and we get through with day 22 pretty quickly, we might revisit that. We will see. But yeah, for now, let's look at today's problem. Crab combat. It only takes a few hours of sailing the ocean on a raft for boredom to sink in. Fortunately, you brought a small deck of space cards. So space cards is actually a link to last year's problem. You'd like to play a game of combat, and there's even an opponent available, a small crab that climbed aboard your raft before you left. Fortunately, it doesn't take long to teach the crab the rules. I highly doubt that. Before the game starts, split the cards so each player has their own deck, your puzzle input. Then the game consists of a series of rounds. Both players draw their top card, and the player with the higher valued card wins the round. The winner keeps both cards, placing them on the bottom of their own deck so that the winner's card is above the other card. If this causes a player to have all of the cards, they win and the game ends. For example, consider the following starting decks, and then they walk through an example. But I think this is pretty simple. Like, we pass this input and then we arrange them in a slice and always take the top one and compare them. We'll see. So let's get on with it. So as every single time, we will start with a function to pass the input. And we will return, and I'm not quite sure. I think we have well defined that we have like two players. So let's just return two stacks of cards, or also known as integers. And we will go line-wise through the input. So we use buffer.io.newScanner and go line-wise through it. And now the first line, so the first line will be a like player 1, and then at some point we will get an empty line and a player 2. So what we will do is just var player 2 bool. So we will just like store a bool whether we are reading cards for player 2 or player 1, and it obviously starts as false. And we will also, I don't know, like we need to read the first line, but we are not really interested in what it is. Errors dot, not errors dot, but io dot error unexpected eof if s dot text is not player 1, return nil dot film dot error unexpected line %q want %q s dot text player 1 right, and then we will say, so if so we first get the line, and if it's empty, not empty, we will basically do the same like this. We will skip another line, which is supposed to be player 2. And continue continue, and we will also say set player2 to true. So with this we handle when we do the when we will do the switch, and otherwise everything should just be an integer. So we will just do struconf.a2i the line nr equals if there's an error, like if it's not an integer, then we will return null fim.error of unexpected line %q expected or want number line, and we will append. So if player2, we say player2 equals append player2 n, else p1. So all of this should be is pretty straightforward. We just pass two lists of integers and add them as return them as the DAG. Right, now if we look at the problem statement, the order is that the first line is the topmost card in the DAG, and the last line is the bottommost card in the DAG. So we always want to draw from the front, and if we put things below the DAG, like if a player wins, it will be put on the bottom. We just append it to the slice. This is pretty easy. Again, we will just check for verification that we can actually read the input. And just to make things easier on myself, we say that log should also output a line with the line number of the log line. So does this build? It does not build. Unexpected no, because I once again typoed return. P1 declared but not. Yeah, this is also fine. Let's just log.println P1 and log.println P2. Input. So yeah, and if we compare that to the actual input, it's 26, 14, 6, 34, 37, and so on until 44, and then 7, 2, 10, and so on until 27. So this looks fine. I guess I also want the test case. This is just you can actually go a step further. We can do something like, we can pretend that we are doing test-driven development by just starting with the test case. This is the test case. Func test read input. I mean, if it was actual test-driven development, we would have started with that, but whatever. We will do exactly the amount of testing that we need to feel comfortable that we did everything somewhat right. Input is a string, and we want p1 is an int, and we want p2 is an int, and want r is a bool. And the first test case is the one we've been given, and I will manually make that this is the kind of engaging content you're all here for. This is the input. We want p1 to be 9, 9, 2, 6, 3, 1, and we want p2 to be 5, 8, 4, 7, 10. We don't want an error, and that's our test case. Range TCS. If so, got 1, got 2, r equals read input strings.newReader. We just call our function and with the input from the test case. If r is null, then like when we get an error when reading the input, we say if we wanted an error, if we did not want an error, we print like we fail the test case. Read input %q equals error want null. tc.input and error. And either way, we will continue with the next test case, because if there's an error, we can't really do anything with the result. If not reflect.deep equal got1 and tc.wantp1, or not reflect.deep equal got2 tc.wantp2 p.errorf read input %q. So now we check that we actually got the results that we wanted. Want %v tc.input got1 got2 tc.wantp1 tc.wantp2. And let's test this. Doesn't work because I forgot a brace or something at some point. Whew. What's wrong? Why doesn't it accept this? Expected type. Oh, oops. Pass. Yeah, our test passes. Yay! And then we want to play the game with deck1. And so the way I will split this up is I will first say write the function to do all the playing, and then a function to score the winner. And actually, we will do it further split into two rounds. Into two functions. The first function will be play one single round, and the second one will be play the entire game until one of them doesn't have a card anymore. Just to make things very, very simple and very, very clear and very, very testable. Func, test, play, round, test-driven development. So, test case. Now, for play a round, our test case will always include a P1 and P2 inputs, which will be slices of ints, and it will what we want as the output. Want 1, want 2, and nothing else. So if say first test case, if P1 starts with let's say we start with like both only have one card, then we want to have player 1 win and get both cards with the winning card on top, and the other one should be null, or like the empty slice, which we will treat as equivalent. And then we can also write a test case where the two are reversed. Oh, YouTube does not return. Apparently I have bandwidth problems again. In this case, we want the two to be reversed. So apologize if the stream is choppy once again. There isn't really anything I can do. I already like paused the stream on my time and on my side, and I'm not. So yeah. Okay, and so yeah, let's just for now start with this and see what happens. I guess we should also just for good measure, we should have a like test case that has more than one card per player. So in this case, player 2 should get the card of player 1. Player 1 should be left with one card that's just the card left, and the other player should be, let's actually use 3 and 4 to make them distinct. Are there tight cards in the deck? It's a good question. I wondered the same thing. Should have mentioned that. Not in the test case. So looking at this, doesn't seem that way, right? Like sorting all the numbers, they do seem to all be distinct. So yeah, the rules don't specify what happens with tie cards. This is why I also wondered, but I think there aren't any tight cards. It's a good question, but given that the problem doesn't tell us how the game behaves in that case, we can't do anything but just assume there aren't any, right? Like, what are we supposed to do? So in this case, 3 will be removed from the stack of player 2, and so they will be left with 4, but then they will also get their 3 and the 1 from player 1 back. Right, so these are test cases. Range TCs. Got 1, got 2 is play round with tc.p1, tc.p2. Once again, I feel compelled to make copies of them, to pass copies, just so that the output is clearer. And so if not reflect dot, we will directly, so I will start with reflect.deep equal just to illustrate what the issue is. Got1 tc.want1 or not reflect.deep equal, not equal. By the way, hi Paul, I didn't actually acknowledge that I know you, and I'm happy that you joined. 1, 2, t dot errorf play round %v equals %v want %v. A lot of %v's. So tc.in1, tc.in2. Got1, got2, tc.want1, tc.want2. So tc.in1, oh, it's not in, it's p1 and p2, whatever, and missing return, yeah. And test-driven development, we first need to make the test go red, and the test is red. Way. Now let's make our tests pass. So what we will do is we will just draw from both players. So one thing, for now we will just assume both still have cards. So we will just assume we will never get called with empty decks. If one of the decks is empty, the game is over, so there shouldn't be any more rounds to be played. So we say card 1 is gonna be P1 0 and P1 1. So so this basically directly slices off the first card from the slice, which is the topmost in the deck. and assigns the result to a new variable c1 and to p1. And then we will do the same with c1 and c2. And now if c1 is bigger than c2, we say, in this case, player 1 wins, and we say p1 equals append p1 c1 c2, because player 1 is the one who wins, so we give him his own card back, or their own card back, and player 2's card. Else, if c1 is less than c2, the same thing, just with the roles reversed. Else, and now just to be like, to catch errors early. Ta-da! And of course, this will panic if we ever get past empty decks. This will just panic, which is fine. And then we return the modified decks. It's super straightforward, but it doesn't work, or our test cases are broken. Let's see. Yeah. So this is actually this is confusing, because these test failures seem to indicate that, wait, everything is fine, right? Like we got this and we want this, and that seems great. And the reason this still fails is that we use nil here instead of the empty string. So if we use the empty string here, the empty slice here, God, for some reason I have like flies in my room. It's annoying. Then this will pass. And like reflect.deep equal will treat nil slices and empty slices as different things, because they are different in the Go language proper. But we want to treat them as the same, and what we will do is we use the same thing we used yesterday for that. We will use the Kimp package. Kimp is a package used for testing, mainly to compare things with more flexible notions of equality than like just reflect or just straight comparisons. So it has multiple functions. It has a diff function. It has an equal function, which is the one we will use. And then you can pass options, and these options can do things like ignore emptiness of slices and stuff like that, or like ignore order or whatever. So you can like get quite flexible reflection-based comparison operators that are useful in testing, because it makes the testing code easier to read. So we will use compare.equal got1 tc.want1, and then there is in KimpOpts, I think. Yeah, in KimpOpts is a equate empty option, which is the one that we are interested in. Like, of course, we could also, in our test case, write the empty slice. But like in general, I feel like our test shouldn't fail just because the function returns nil, right? Because in Go, like empty slices and nil are the same except for comparison to nil. So like the result should really be considered the same. It will never happen, but I still think this is nicer than depending on this implementation detail. And then also we need to replace the ones in here. With twos. This doesn't work. This is something where I don't quite know how I should feel about. This is something I apparently never really got. So if we test this now, it still does not pass. Why doesn't it? Why? This should now. I was so proud of myself to use Kimp. KimpOpts.equate empty. Oh, if. And also, like, now all the tests fail. Yes. Yeah, this is better. Now this passes. So yes, we have written a test and it passes. And just to be absolutely clear, I don't really think any of this really needs tests. It's just at least the first half of this task seems trivial enough that might as well like use that to illustrate some things about like testing and things. So now we know how to play around. Now let's play a game. P1, P2 int, and it will return, what will it return? It should return like, it will just return the final DEX. And then we can write the scoring function after that. We will go in very, very, very small increments. So play game. What we will do is as long as either of the as long as both of the players still have cards, we say P1, P2 equals to play around P1, P2. Simple. Right? It doesn't get much simpler than this. And again, let's walk the walk. Let's write the test. Play game. So this game is already a correct ending state. This is also a correct ending state. This test case will change because now we have to actually play the game in our head. Oh no! Now if like this is like what happens after one round. So let's play another round. Player 1 draws a 2. Player 3 draws a 4. Player 2 draws a 4, player 4 wins, and player 2 gets a 2. So, nil. Does not work. Oh, because we use play round and not play game. Apart from that, our function looks exactly the same. Cool. So let's also, just for good measure, let's use our test case from the problem statement as an actual test case. We could also do that upstairs, but let's first do here. So in this, player 1's deck is empty, player 2 deck should look like this. And let's hope this still passes. Still passes, cool. Yay, we feel somewhat confident that our code does the right thing. Cool. And now func score deck. So now let's calculate the score, and the way the score is calculated, this is written here, is basically the lowest card in the deck has a weight of 1, the second lowest has a weight of 2, the third lowest has a weight of 3, and so on. And so you always multiply like the weight with the value of the card, and then you sum it all up. So again, easy enough function to write. Var score int. Of course, the score can get quite high, technically. So we'll see if maybe we need to use bigins for once. Because whenever you multiply things can get quite large. For I value equals len for range deck, so for all cards, we say score, we add as a score the value of the card multiplied with its weight, and its weight is, well, the highest position, card 0 will have a weight of length of the deck, and card 1 will have a weight of deck length minus deck minus 1, length of deck minus 1, and so on. So we say len deck minus I, and I think this is correct. Return score, and let's do the thing. Func test score deck. Test cases are deck and the score we want. And we will just conveniently start with the test case we have from the website. and we know that the score we want is 306. And of course we could like write more test cases, but for all test cases, got is score deck tc.deck. If got is not tc.want, to.errorf score deck %v equals %v want %v. tc.deck got tc.want. Go test. Test passes. Cool. Our code obviously works. So yeah, obviously, like these are not the best tests in the world, but they are definitely what I would do, like what I would manually test. So we might as well write an automated test for that and then see what happens. So yeah, so now we can just say p1 p2 equals play game p1 p2. And then if len p1 equals 0, dot printf player 1 with a score of %d, score deck. Yeah, sorry. You don't have to apologize for being late for the record. I usually try to start actually at 5 p.m. German time, but the last couple of days I've been really bad. So I'm on vacation now, so I'm really bad at eating before doing things, and so the times are sometimes a bit wonky. If I don't want to sound desperate and needy, but I tweet out the current time at my Twitter, which is at the Merovius. I should probably put that in the description or something. I don't know. I can actually write it in a chat. Cool. So score deck, it's actually if the length of the first deck is 0, then player 2 won. So we should actually do it this way. Else, and we definitely know one of the two is the case, right? So go bird day 22 with the test case. Have we? No, I have not copied it. Let's look at the test case. This is now an end-to-end test with a score of 306. Yay! So this seems to work. Let's run it on our input, and this is the score. So yeah, the problem today, at least the first part, seemed really simple. So I've been going really slow with like writing copious amounts of tests. Just FYI, like I literally like split it up into the smallest possible units I could think of, and then like wrote a couple simple tests for each unit, and it still only took me half an hour to finish the first part. So the first part seems fine. Let's look at the second part. You lost to the small crab. Fortunately, maybe I'm player 2. Fortunately, crabs aren't very good at recursion. To defend your honor as raft captain, you challenge the small crab to a game of recursive combat. Recursive combat still starts by splitting the cards into 2 decks. I have tiny flies. You offer still starts by splitting cards into 2 decks. You offer to play with the same starting decks as before. It's only fair. Then the game consists of a series of rounds. Like, yeah, this is how it works. I will just use the same random thing and then change the rules on you. It's super fair. Then the game consists of a series of rounds with a few changes. Before either player deals a card, if there was a previous round in this game that had exactly the same cards in the same order and the same player's decks, the game instantly ends. Oh god, no, again. If there was a previous round in this game that had exactly the same cards, in the same order, and the same player's decks, the game instantly ends in a win for player 1. Why player one? They are asymmetric rules. That's not fair. This game is rigged against the poor crap. Instantly ends in a win for player one. Previous rounds from other games are not considered. This prevents infinite games of recursive combat, which everyone agrees is a bad idea. Otherwise, this round's cards must be in a new configuration. The players begin the round by each drawing the top deck. If both players have at least as many cards remaining in the deck as the value of the card they just drew, the winner of the round is determined by playing a new game of recursive combat. This is complicated. Otherwise, at least one player must not have enough cards left in their deck to recurse. The winner of the round is the player with the higher value card. As in regular combat, the winner of the round left in the deck to recurse. The winner of the round is the player with the higher value card. As in regular, the winner of the round, even if they won the round by winning a subgame, takes the 2 cards dealt at the beginning of the round and places them on the bottom of their own deck. Yeah, okay. Note that the winner's card might be the lower value of the 2 cards if they won the round due to winning a subgame. If collecting cards by winning the round causes a player to have all of... This is super complicated. This is Calvin Ball. Wait, where was I? Due to winning the subgame. If collecting cards by winning the round causes a player to have all of the cards, they win and the game ends. Here's an example of a small game that would loop forever without the infinite game prevention rule. So 43-19 to 29-14. Can you also explain why this loops forever, or like... Okay, so wait. So must be if both players have. Okay, so let's ignore the instant rule and try to understand the rules. So both players draw a card. Player 1 draws 43. Player 2 draws 2. If both players have at least as many cards remaining in the deck as the value of the card they just drew, that is not the case, because player 1 does not have 43 cards. The winner of the round is determined by playing a new game of recursive combat. See below. Then I don't understand why this would lead to an endless recursion, because like in this game, player 2 would just win the round. Oh, player 2 would win the round and then place a2 and therefore the 3 at the bottom. Player 1 has... This would just end after 2 rounds, wouldn't it? I don't understand this game. I don't understand your problem. This is... During a round of recursive combat, if both players have at least as many cards in their own deck as the number of the cards they just dealt, the winner of the round is determined by recursing into a subgame of recursive combat. You already said that. For example, if player 1 draws the 3 card and player 2 draws the 7 card, this would occur if player 1 has at least 3 cards left and player 2 has at least 7 cards left, not counting the 3 and 7 cards that were drawn. To play a subgame of recursive combat, each player creates a new deck by making a copy of the next card of... Each player creates a new deck by making a copy of the next cards in their deck. The quantity of cards copied is equal to the number on the card they drew to trigger the sub... Have you watched, like, if you watched How I Met Your Mother, there's an episode where, like, the joke is Marshall likes to make up games, and so he makes up a game for Lily's birthday, and it's the most convoluted BS game ever, and this is that. I don't have enough cash in my CPU to like understand the rules. The quantity of cards copied is equal to the number on the card they drew to trigger the subgame. During of the next cards in the game. Okay, I kind of understand what this means. During this subgame, the game that triggered it is on hold and completely unaffected. No cards are removed from players' decks to form the subgame. Yeah, that's fine. If player 1, yeah, that's fine. Here's a complete example of gameplay. Okay. Okay, so I will just move that to workspace 2 and leave it on the right and just go through it like line by line. So I think we want to start by, one thing that I want to start by is by writing a small helper to copy a deck. And it's a super simple helper, but it will, like, we need to do a lot of copying, and like writing append whatever is always gonna be too annoying. So we will first implement a round of recursive combat and see what happens. Func play recursive round with 2 decks, and we will see what happens in this case. I assume we still want to return 2 new decks after the round. Have at least as many cards in their own deck as the number on the card they just dealt. The winner of the round is determined by recursing into a subgame. Yeah, let's just assume this is the case for now. So we will only call this function when we have enough cards. So to play a subgame, each player creates a new deck by making a copy of the next cards in their deck. Let's do this. P1C is a copy of the card. Okay, so let's first draw. And again, I will write a helper for that because I'm getting confused. The card and the new deck. And we will say C rest equals deck 0, deck 1, return C rest. Okay, so first P1 draws a card. And then player 2 also draws a card. And now, if the length of the deck of P1 is less than the card they just drew, they immediately lose. So we say, I don't know. Obviously, like, the return values aren't super appropriate, so we will have to figure out how to communicate that. If then P2 is less than C2, panic, player 2 lost. So otherwise, we make a copy of the first C1 cards, not a copy. So both make a copy of that deck. During the subgame, the game that triggered it is on hold. Yeah, that's fine. That's P1 and P2. And completely unaffected. No cards are removed from players' decks to form the subgame. And then, what do we do with the copies? I guess we call play around. And the game ends once one of these is done. If there was a previous round in this that had exactly the same cards in the same order, the game instantly ends in a win. This we will deal with later. Otherwise, the round's card must be in a new configuration. If both players have at least as many cards remaining in their decks as the value, the winner is determined by playing a new game of recursive combat. This is what we are just doing. Otherwise, at least one player must not have enough cards left in their deck to recurse. The winner of the round is the player with the higher value card. Otherwise, at least one player must not have. The winner of the round is... So we want, in this case, we want to say if one of them does not have enough cards, the winner is the one with the higher value card. And the winner, just as previously, will add the winning card to both cards to the end of their deck, starting with the winning one. So this. The rules are far too complicated to understand, in my opinion, but whatever. Just write code and then I understand what it does, which I guess is my job, but yeah. And then that's, I guess, the round done, right? The player... otherwise, at least one player must not have enough cards, so otherwise they are left. So, and now we determine the winner by playing another round of recursive combat. Must be in a new configuration. This is something we still haven't done. I don't like that. Before, if there was a previous round, like this is also something we haven't done. As in regular combat, the winner of the round takes the two cards dealt at the beginning of the round and places them on the bottom of the round deck. Note that the winner's card might be the lower valued of the two cards if they won the round due to winning a subgame. If collecting cards by winning the round causes a player to have all of the cards, they win and the game ends. Small game during a round of if both players have at least as many cards in their own deck as the normal cards they just dealt, the winner of the round is determined by recursing into subgame of recursive combat. Okay, so basically we want to say the subgame outcome will be play game recursive of, and like they use these copies for that, I guess. Is that the idea? I don't know. This is not interesting. I feel like oh, we made up like rules that are so freaking complicated that you will not understand them, and now you have to implement them. I don't know. It's just by moving through it word by word. So func play recursive game, or play game recursive, I guess. So and now we want that if len sp1 is 0, then player 2 won the subgame, and we say the deck of player 2 gets the card P2 and their winning card. Else if len sp1 equals 0, P1 equals append P1, C1, C2. Right, and now like if whoever won the recursive game will get the card, and then we will return P1, P2, I guess. So this should be one recursive round, assuming that play game recursive is implemented correctly. I think. I don't know. What do I know? Okay, so play game recursive. We still have not implemented the if the state of the cards is exactly the same, which we will do at the end. Okay, so play game recursive for len p1 greater than 0 and len p2 end greater than 0. Otherwise, return p1, p2. Yeah, I guess play recursive round p1, p2. Okay, p1, p2 equals. Okay, so now we enter the game. We say as long as either player still has cards, we enter a recursive round. The recursive round starts by drawing a card from each pile, from each deck. Then if one of them does not have enough cards to recurse, we determine the winner by whoever drew the largest card, give them their winning card and return the new deck. Otherwise, we play a recursive game. And if the player 1 lost, player 2 gets their card and the other card. Otherwise, player 1 gets their card and the other card. And I guess that's fine. And we make a copy to not efface. So I think this is fine, except the fact that we have not yet looked at whether we have an infinite recursion. But one way we can do that is, I guess, we will store all states in a map and we will make this a recursive function. We can't really make this a recursive function. Yeah, so because the round and the game are mutually recursive. So we will make it a recursive function, but we will... Okay, so first let's make this a recursive function. Play game recursive, and we will add the loop. And we will inline all of this. And we will not return things, but this will just change all the state inline, right? And then at the end we will return p1, p2, and this will be play the unexported play game recursive. So this should now do exactly the same thing, just in one function, which has the advantage that we can now take all of this and inline it as a play game recursive, or I will just call it rec because that's shorter. And this will contain all of this, and we need to we actually need to do this, and I will explain in a second what I'm doing here. Okay, so now everything is still exactly basically the same. We now have one function that plays the entire game, but we have done it as a function literal inside the play game recursive, and we need to like first declare it and then assign it, because we want to call it recursively. So the variable needs to be defined before we like the variable needs to be declared before we write down this function so that it can refer to itself, right? But and the reason to do all of this is that we can now have a past states map, which will just store all the states we've seen so far. And we can't use slices. Slices are not comparable, so we can't use slices in map keys, but we can use strings, and we will use the same trick I used earlier in a different thing, which is that we will just use as a key, we will just use a sprinted version of that. So what we will do here is we will say if past states fim.sprintf %v, we will just concatenate the two stringified slices as a key. So I will actually say we say, in this case, player 1 instantly wins. I'm not quite sure how I should encode that in the deck, like how that would be reflected in the deck. But I will just say, I just assume that this is not the intended outcome of the game. I don't know. I don't know if any of you have read the rules and think they know what should, like how the cards should be ordered. If player 1 won due to this condition, let me know. I will just do this for now and hope that this is not a case we actually run into, but that it's just there to make the things well defined. Past state k equals true, right? And with this we done the, if we have already seen the state, we are done, right? Technically speaking, we should actually do it here, I guess. Yeah, I think we actually should do it at the beginning of each round, not just at the beginning of the sub game. But yeah, this should actually, I don't know, this should work. We'll see. Okay, let's see. We will also play the game with copies of P1 and P2. Result 1, result 2, just so that we can reuse them for the recursive game. Now result 1 is play game recursive P1, P2, and let's do the same thing. The recursive game. Yeah, I don't know. Let's see what this does. Let me move this over for a second. You see that by confusing the heck out of me, the game disincentivized me to actually do the... Let's write tests for all of this again. Is this... No, it's not. Day 22 doesn't work. 25 recurse if not enough to return. Do we have a test case? Is this the same test case as before? 9, 2, 6, 3 and whatever. 9, 2, 6, 3 and 1. Yeah, okay. So let's copy this case and see what happens. I am not super confident that this will just work with a score of 80. It does seem to work, and it, yeah, player 1 won because we cheated by changing the rules arbitrarily, but we have the wrong... Oh! From the cards they have in their original deck. Not in the result deck. So this actually, it doesn't even matter what this will be. Okay. So we need to again work on a copy so that we can retain the original deck, and let's hope that... Nope, still the wrong score. What? Also, player 2 is supposed to win, not player 1. Okay, what's our outcome? Our outcome is, it's not even that one of the... Wait, how? rec. Oh, because this returns. Oops. This now needs to continue. Okay, now at least the one of the players actually won, but it's still the wrong set. Well, apparently I misunderstood the rules. Who would have thought that I would like... Oh. Okay, printf debugging for the win. Okay, let's start here. So log.printf starting round, and we will actually do a indent so that we can see what game is which. %s starting round with %v and %v, and the this will be strings.repeat. Let's just make that shorter. Indent p1, p2, and here, so printf debugging, indent, and what else? Yeah, this, I guess. One player does not have enough cards. And log.print recursing into subgame. Cool. Sounds good. Player 2 1 subgame, indent. Player 1 1 subgame, and now we can do this, and this already aborts immediately. What? Okay, let's see. How does this go? Let's compare the two outputs. So player 1 wins round 1 of game 1. One player does not have enough cards. Higher wins. I should actually say who wins, just to clarify. %s, player 1 wins with card %d. Indent C1. Player 2 wins with card 2. Okay, let's again compare. Player 1 wins with 9. That makes sense. Now, starting round. This obviously is not the right round. Why does it do this? Why? What? Okay, at least we found the bug fairly quickly, or one bug. Starting round. P1 equals append P1 C1 C2. Wait, what did I do for draw? Did I screw up? What? Someone explain to me what I'm doing wrong here, because I don't understand it. Why does we assign to P1 and P1 is, oh, this is why. Okay, that makes sense. So this is why shadowing is sometimes bad. We are creating, like, I used colon equal so that I could create the card, and in the previous incarnation this didn't matter because we had a function, but now we have a loop, and so now this also creates a new version of P1 instead of modifying the one that we loop over. So that's why it doesn't retain the change. And now it does. Now it does a lot of more stuff. The score is still not correct, I guess. Let's see. So player wins round 1. So now next game is 2-6-1-9-5, 8-4-7-10 is okay. Player 2 wins with 8. Yeah, because they don't have enough cards. They don't have 8 cards. Now round 3, starting round. Well, it takes a long time to actually start a subgame. Here's the first subgame start, and it starts when we do this 4-9-8-5-2. So this is our round. Until then, we have the same thing. Yes. So recursing into subgame. The subgame starts with 9-8-5-2 and 10-1-7. Cool. And the higher card wins. Player 2 wins with 10. Wait, do we... Let's first see how this... Let's just walk through it one by one. So the subgame ends with a round like this. Does this subgame also end like this? 1 and 7, 5, 10, 2, 9, 8. And player 2 wins with 7, and then player 2 won the subgame. Great. So now back to game 1. Cool. And 9-8-5-2, 10-1-7-6-3-4, and we just play higher cards and player 2 wins. Then 8-5-2, oops, 8-5-2, 1-7 something something. Player 1 wins. Cool. Now 5-2-8-1, 7-6, and so on. Player 2 wins. Next round 2-8-1, 6-3, whatever. Recursing into subgame. Great. So this is this one. Now subgame. Starting round 8-1, 3-4, 10, 9, 7, 5. Higher wins. Player 1 wins. Cool. And then the subgame immediately recurses. Cool. 1-8-3, 4-10, 7-5, recursing into subgame. So this is the subgame that we recurse into. This is game 4. 8, 10, 9, 7, whatever. Player 2 wins the subgame. Cool. This is what we have. This does seem like we did everything right? Like for now. Round 2. Game 3, 8-3 and 10 whatever. One player does not have. Player 2 wins. Starting round 3 and whatever 8. One player does not have higher wins. Player 2 wins 9. Player 2 won subgame. Starting round with 8-1 and 3-4, 10, 9, 7, whatever. And then we recurse into subgame again. This does look correct. Then we start the subgame start around with 8 and 10, 9, 7. Oh, this says we saw the state before. Player 1 wins. This seems to be where we diverge. So we say we saw the round before. They say they didn't see the round before. Is it maybe per subgame instead of per? Like, are we supposed to do it to reset that state in the subgames, but like if there was a previous round in this game, yeah, okay, so I guess we have to do that. So instead of doing this, we actually do it per game, and so we could have actually done it simpler, but whatever. As long as we get the right results. Won the recursive game with a score of not the one they got. They got 2-1, and they got 756, 241, 10, 8, 9, 3. Yeah, but we got we got the same results. 756, 241. They have in their original deck using the same rules as in maybe now we need to not use the original deck after all. Maybe they've been lying to us after all. (219, 291). Yeah, so this actually seems to do the thing. Oh god, this freaking recursive whatever game, far too hard to understand. Great. Great, cool. Yeah, I will not try to improve this. I don't think so. Maybe we'll see. Let's first let's leave the logic in and let's run it on the input, but let's get rid of stdr and let's see how long that takes. Oh god. Okay, now the question is, oh, okay. Woohoo. I will call this a win. It did actually finish. Let's see if this works. Yay! Got both stars in a reasonable amount of time. Okay, so it's obviously not the fastest code. It did take a couple seconds to run, but it didn't take that long to run. So I guess there's that. So let's first check what happens if we like remove all the indentation or the logging logic, because even though we discard the logging output, it still takes time to print to def null, and we have seen in the past that things ran a lot quicker if we didn't have that. Okay, it does run a lot quicker, but still not super quick. So I think I could I think given that we now don't have to close over this, we can but for the record, get rid of all of this. No, we can't. Why not? P1, P2, past states. Continue wasn't correct after all. So this should work. Yeah, okay. Yeah, so now because we don't close over common states, so now we can just have a simple recursive function. I don't know. Just because I'm interested in, I would like to, and because I think it's funny. So one thing I would like to do, I think, is, as I mentioned, I revisited day 20. and I got the first part done. I didn't get the second part done yet. And so I might try that with the time remaining. But I also would like to try something, because like this thing is technically a hack. I mean, no, it is a hack. And I would just like to try a different, and I think is fun to show. So as I mentioned, the reason we use strings and like sprint is because Go, like, we can't use slices in in maps as keys. But there is a hack to be able to use a linked list as a key in a map. And this is, so instead of using slices, we will use linked lists. And the way we do that is we say an element of the list is gonna be, it will obviously like have a value, which is the card value, and it will have a next element. But instead of doing like, usually you would do a singular list like this. But instead, what we will do is we will store an empty interface in here. And the reason for that is that, well, so the definition of equality is interface values are equal if both their types are equal and if the values are equal. And the definition of equality on structs is two structs are equal if all their elements are equal. And so by doing it this way, we get a recursive definition of equality on these structs. Like if next always contains notion of equality that we can then use as a key in a map. So what we can say is, we can write some functions to work with them. For example, we can redefine draw as a func on an element, which is our list, and it will return a card and a new list. I guess technically it should return, yeah, anyway, we will see what happens. And it will, what it will do is it will return, technically this should really be empty interface. It needs to be. We will just return l.v and l.next. So obviously this removes the first element of the list. And append is going to be annoying. Okay, so instead of actually working with linked lists, what we will do is we will say from slice will be a function that takes an int_slice and returns a list or a list. And we say var l is our list for I len s minus 1, I plus plus, I minus minus, I greater or equal than 0, L equals L with a value of si and the list as the next element, and then we return L. And so this will build up our linked list from the back, from a slice. I guess we could also use like, because we are only interested in comparing them. But whatever, we will just go from the back for now. And then past states will be, well, I guess we should use two interfaces as the key, an array of two interfaces as the key, and then say this is from slice P1, from slice P2, and yeah, I think this is fine. 1 to 2. Let's see. It returns the same thing. Yeah. So this is of course like a crude hack, and you should probably never do this in practice. I feel like it also ran a bit a bit faster. We can verify that, maybe. What happens when we remove all of this? Let's not remove all of this. Let's just go back to a string map here. Maybe I'm wrong. Maybe it's not faster. Doesn't seem that much faster. It's slower. Okay. So yeah, don't do it. But anyway, it's a fun hack in my opinion. Like basically, it allows us to have to compare variable length lists with Go comparison operators. But yeah, let's remove this. Okay, so let's see. We are done with today's problems. Let's commit. And let's just have a look at day 20. So, day 20, the bane of my existence. In day 20, the goal was that we would have, we have a list of quadratic map chunks, and we are supposed to assemble a map from them by finding out how to rotate and or flip the pieces and fit them together. And conceptually that it wasn't very hard, but it just it took me 2 hours and I still wasn't done, and I was super frustrated. And last night I couldn't sleep, and so I thought, let's just use the time to revisit this problem. And so I did, and I now, as you can see from the Advent of Code start page, I have 1 star on day 20. Yay! So, and so what I can say is, I don't know if who of you watched the day before yesterday. But what I do is the tiles have just this. They are just they have their index, which is this ID. Then they have a slice of strings for each row. And what I now do is super complicated and ugly, but I use a map that stores the edges. So it will store this string, and then the string read down, and this string, and then everything flipped, and stores in a map. So previously I stored in a map how often I rotated or flipped the slice, the tile, to get to this edge. But now I will just say, okay, this map stores as a string, it stores the topmost line of the tile, and as a value it will store this edge struct, which contains a tile index number, because actually this index is not the index in the array, so in the slice, so this tile index is actually the index in this slice, and the resulted, the rotated and flipped tile. And so we just go through all the tiles, rotate them 3 times by 90 degrees, and I wrote a function for that, which I've already showed then, that just rotates a tile. Then it flips the tile upside down, and rotates it again 4 times, and so now we have all possible orientations of a single tile, and for each of these orientations we have what the topmost edge is in this map. And so we can, if we want to glue 2 tiles together, we can just look up what the edge is that we want to glue on, look it up in this map, and then find the correctly rotated tile. And then we still might have to rotate it, because we will find a tile with the edge we are looking for at the top, and we might want to have it at the left or the right or whatever. But at least we have a well-defined tile and stuff. And so then this code is exactly the same as it was before. I just go through all the edges and I count how many. This this uses a slice of edges as the value, because every edge, most edges will appear twice, because they will, like, there are two tiles that can be glued together, and the edge will appear in both of them in one orientation or the other. Like, that's the entire point. But some edges will only appear once, and those are the edges at the border of the entire map. They will be unique. They will only have one appearance. And so I will just count that we have the correct number of those, and like and also find for every tile how many of the edges of this particular tile are of this unique kind, of this border kind. Because I want to find a corner, and a corner is one that has exactly two edges that don't appear in anything else. And so this is like what this code is doing. And this is just debug output. This code, I think, is not actually needed. Yeah, this is not needed. This actually built a graph with an edge between two tiles if they could theoretically be glued together, because I thought it would be useful, but I didn't end up actually using that. So, yeah, still builds everything fine, I think. And so now we find a corner, and we do that by looking through all the tiles and see if they have exactly 4 unique edges. 4 because every edge appears twice. Anyway, yeah, so yeah, trust me, this finds a corner, like the index of a corner. As I said, at this point, I'm like, I will not really fix this code. It's not the greatest code. I don't quite understand why it works, but it works, so let's just leave it. Then we find we know what we use as a corner. So basically there are 4 candidates for corners, but it doesn't actually matter which one. Like, we have no information about which corner of the map is actually like the upper left corner and what orientation, but it also doesn't matter for the problem, at least for the first part. So we just select one of them. And then, like, we look which of the 2 edges are the ones that are at the border of the map, right? So that we can rotate the tile so that it has those 2 at the left and the top. And again, the code is not the nicest one. This function just extracts an edge, like it does the assembling of the vertical string and whatever. And so the really fun part starts like around here. So this is just a small helper function I wrote to remove a tile. Like, once we've used a tile up in our final assembly of the map, we discard it so that we can't encounter it again. This is just a helper to print it, obviously. And ordered will now be the correctly ordered map, starting from the top left, going to the bottom right. Right, so we know the map is square, like has a square number of tiles, so the top left tile will be the corner that we selected, and we rotate it into the correct orientation for the edge that we found, and we print for helping. Then we remove it from the edge map. Basically, it removes the tile that we already, it removes all edges from this map that refer to this tile, with the reasoning that if we look for an edge for a tile to glue to one that we already have in our assembled map, like, we obviously don't want to reuse one that we already have. So we remove the corner, and then as long as we are not done, we check, is this a new row or not? Right, n is the side length of the map. If it's not a new map, a new row, we want to glue a new find a glue to a tile to glue to the right side of the last element we added. So the last one is this. We look at the right edge of that tile, and this is one where I think my mistake was when I tried to solve this the first time. We actually have to reverse the edge that we are looking for. Right, like if we have a map that is like 1, 2, 3, 4, 5, 6, 7, 8, 9, and like we have a map that is, let's say, 3, 6, 9, A, B, C, D, E, F, right? Like, these two tiles, like we have 369 and we have 369, but we can't actually glue them together, because if we rotate this correctly, this will be 369 A, B, C, D, E, F. And now we have a, wait, I did that wrong. Yeah, if we rotate it left once, we will get 369 A, B, C, D, E, F. So this will be the rotated tile. And now we have a mismatch here, right? Like, so we are not actually looking for one that has 369 at the top, but we are looking for one that has the reverse of that at the top. We are looking for one that has like 936, so the flipped version of this tile, right? So this is something that I didn't think of when I when I tried to solve this 2 days ago. So we reverse the right edge. We are looking that like we are checking that we find exactly one tile that has this edge, because we removed the ones that we are gluing to already. And then we just rotate the tile to the correct thing, to the correct orientation. We append it to ordered, and then we remove it from the edge and continue. And if we have a new row, we don't want to glue it to the right of the last tile, but to the bottom of the first tile in the previous row, which is this one. But apart from that, we do exactly the same. So we use a different edge. We use the bottom edge this time. We still reverse it for the same reason. We don't have to rotate it in this case. And then we remove it and append it. And like, it turns out this actually works. Like, this actually does what we want. And so like, this is the result that we get. And you can see like that these are all correctly matchingly glued, right? And then like the solution number was just this multiplied with this, multiplied with this, multiplied with this. And so I just print that out here. First part, like this was the solution for the test case for the first part. So this is just to explain like where I got last night. And at that point I was pretty happy because I finally got the star that like haunted me. So much for part 1. If you did not understand any of that, I will not blame you, but I also will not explain it anymore, because oh my god, this code is so freaking ugly. And yeah, now let's try to do the second part, which is a bit easier. Hopefully, we will see. I'm not quite sure I understand it correctly yet, but we will try. The first thing we have to do is now glue the map together by removing all the edges from all the tiles and then adding them together. And like I already wrote that. So this is kind of the map that we assembled by removing the edge tiles, the tile edges, because the tile edges were just gluing instructions. And so now what we're supposed to do is on this map find sea monsters. And sea monsters are these things, right? Like a set of hashes in this orientation. And one of the things is that in places where there's no sea monster, we are allowed to have either hashes or dots on the map. But like we do have to need to have this relative orientation of sea monsters. 2, 4, 6. Yeah. And like to make things worse, we still don't know what orientation the map is. So we also have to try out all orientations. Right, when looking for this pattern in image, the spaces can be anything, only the hashes need to match. Also, you might need to rotate or flip your image before it's oriented correctly to find sea monsters. I would interpret this as there are either 0 sea monsters or there is at least 1 sea monster. So we can find the correct orientation just by counting sea monsters, and if they are 0, we are done. And so what we are supposed to do is we are supposed to find all the sea monsters and count the number of hashes that are not part of a sea monster. So I guess like one question that I had was, what if sea monsters overlap, right? Like the head of the sea monster could like intrude into the body of a sea monster at a different part. And I don't like that. But whatever, we will just deal with that. So I think what we will do is we will do a very, very dumb thing. We will go through all the maps. We will find all sea monsters, and we will kind of assemble a new map that has that replaces all the sea monster hashes with dots, and then we will just count the hashes. I also thought we could theoretically just count the number of sea monsters and then remove, just count all hashes in the entire map and remove n times the number of hashes in the sea monster. But given that, again, I'm not quite sure whether or not they can overlap. They may overlap. Like, replacing them seems easier, and this is also why we need to make a copy. So, but this actually, this does seem pretty simple to do. I hope. We will see. And so what I will do is func count sea monsters. And it will take a tile as a map. So we will reuse this. So I reused the same tile type for maps because we already have rotating and flipping functions for those. And the like the code for the tile does not care for all of these does not care about the dimension of the tile. And this will just return an int. That's fine. So this is the sea monster that we are looking for. And one thing I would like to do is I guess I can also do this. And the reason to do this is that this is now a regular expression that will look for hashes and will ignore dots and like will ignore whatever happens in the rest. So we can just yeah, do this. Var sea monster will be a go dog regexp will be a slice of regexps. And we will do that in init to actually assemble that, and we will say sea monster equals append sea monster regexp dot must compile our first sea monster string, and I will use a raw string literal just for right dep. And then we will do the same twice over. And I don't know if this works. Ha! It does. Sorry for yelling into the microphone. Yep, so now our sea monster hopefully contains regular expressions for all the sea monster lines. And when I count sea monsters, what I would like to do is I would not like so basically what we need to do is we need to find position of lines. But instead of like starting with the first line, which I assume will have quite a lot of matches because it will basically be just like, well, anything that has a bit of space and then a hash, we will start with this one, which will hopefully have a lot fewer false positives. So we will find all occurrences of this line from the first line on. Then we will check if the line above and the line below will also match this. And if it does, I guess we are done. For all rows, actually for I equals 1, I less than len m dot tile minus 1, I plus plus, because we don't need to check the first and the last row, because the first and the last row can't have the rest of the sea monster below or above. And then we will say, I want to say that I basically never use regular expressions. So I am not super familiar with the Go API to use them. But I think we are interested in this basically. So this should give us find, or what does find all index does? Find all string index. Yeah, find all string index. is the all version of find string index. It returns a slice of all successive matches of the expression as defined by the all description. Thank you very much. So the all is, if all is present, the routine matches successive non-overlapping matches. We do care about overlapping matches, technically speaking. Empty matches abutting a preceding match are ignored. The return value is a slice containing all of the non-all. Okay, we do look for overlapping things. Is there no all characters, code points? There are 16 methods, all string submatch index. So what is the return value is a slice identifying the successive submatches of the expression. Submatches are matches of parentheses submatch. This is not what we want. This is successive non-overlapping matches is something that I don't like. Because we do care, we don't just want non-overlapping matches. We want all matches. Fine. So let's first look at find string index, and then we will look at the rest. And this is getting annoying, but we will power through. So we first look for find string index, I guess. So find string index will find matches and submatches are identified by byte index. Result elements the index of the nth submatch. The match of the entire the pair for n equals 0. So the first, hopefully the result will be 2 integers that are the match. So let's check whether that works. cmonster1.find string index in m.tile_i. Find string index. So this should be fine. Returns a 2-element slice of integers defining the location of the leftmost match of n in the regular expression. The match itself is at this. Okay, so so this will find the first match. If len log equals null, we continue. So if we don't get a location, then we continue. Otherwise, log 0 will be the match that we are looking for. So, and then we actually need to handle if there are more than one matches, but we will do that later. So for now, we say, we don't want to count cmonsters. We want to replace cmonsters, because counting alone doesn't help us. Out is a tile that has as the index m.index, and as tile we don't know yet. Yeah, okay. Wait, this also might have to be oh god, okay, so this is actually still super ugly, this part of the problem, but we will desperately try to power through. So this is one match. We have found a match, and we will say, let's first write a function that just finds cmonsters for the simple reason that we will first find the correct orientation. I assume the code to replace them will be very similar and will share a lot, but let's just first count, because we need to find the correct orientation of the map. Oh, I actually also don't have too much time again. So now we want to see, if go doc now we look for just match string is the next thing that we want, and now we want to basically match the corresponding location in the line above and the line before. So cmonster, if not, cmonster 0 dot match string m dot tile I minus 1 from log 0 to log 1. Yeah, so this is basically, does the find thing, the match itself is at this. Great, so yeah, this is correct. So yeah, we will extract the same location in the row before. Continue. And then we will do the same with cmonster2 in the line above. Otherwise we will return true. Yeah, so this will just find us cmonsters. It will not yet do anything about them, right? And let's now see that we can actually find cmonsters. So, and for that we will just walk through all the rotations of the map. If find cmonsters m fim.println println correct orientation, and we will do this. Actually, let's just say break. And do this again. Otherwise, m equals rotate tile m. Oh, actually, this doesn't work. Let's write a quick helper function. Func find map orientation tile, because we need 2 loops and everything. Return m, and we will also do and is this okay? Zip. Otherwise we flip tile. If none of the rotations contains cmonster, we will flip it, and then we will go through all orientations again. Otherwise we will return m and false. So and now we can actually say m okay is find map orientation if not okay, log dot fatal f could not find cmonsters. And now we go build. Nope. 72. Rotate tile by 1. Rotate tile by 1. Missing return. 420. Nice. Sorry. Correct orientation is this. It's the same orientation, but I think I actually tested this, and I actually figured out that I do have the same orientation as they have. So yeah, we do find the correct orientation, hopefully. Can we do it on the input and see what that does? This something. Correct orientation is this. This is the map. Now let's count all the cmonsters. So no, not like this. Cool. Okay, now we know that we have the correct orientation. Now we say func replace cmonsters. Actually, you know what I want to do? I want to be cheeky and see whether the matches overlap. So var okay bool return okay equals true. So instead of this, we will, instead of just exiting after the first, we will fim.println printf Found CMonster at... Oh, this doesn't give us... Wait, can they overlap horizontally? I guess they can. Can they? No, I don't think they can. Right? Like this string, right? Oh no, because there could also be things in here. So they probably can overlap horizontally. Great. So no, we will not do this. We actually have to go through all of that and like do it. Func. Replace CMonsters, I guess. Oh god. Okay. So some of this is the same. Not a lot of this is the same, to be honest. So we will find a location. So now the issue we are having is that we we now have to keep track. Like we now have to find more than one CMonster in a row, possibly. So we actually have to do a loop. Var j for j less than len m dot tile I. Now, and we will do this in a loop. And instead of finding it in everything, we will start at j. If log equals null, continue. Great. Okay, so I think what I want to do is, what do I want to do? I think what I want to do is I want to first assemble all CMonsters that we find, and then go about doing something about them. Var pos will be will have two ints. And so, like, first I will even go one step further, and I will even say, let's say that we only look for matches of the middle row. Wait. And this will be a slice of two ints. Just because this is easier to wrap your head around then, and you don't have we don't have to worry interspersing that with replacement and printing and whatever code. Okay, so if we can't find one, then that's done. Otherwise, we say pos equals append pos. Like, this code is basically just trying to, just a workaround that the go regex matching doesn't have a non-overlapping, an overlapping match function. Otherwise, this would be a lot simpler. So otherwise we will append the position with the row that it's in and the start that we found it in, because like the width of the match is always the same because we just use single character matchers. So we first append this to the matches that we found, and then we will set j to log 0 plus 1. So now in the next thing we will start at the first position after the last match that we found, and this will give us all overlapping matches, hopefully, right? And then we can actually say yeah, this seems fine, I guess. So if log is null, we can actually break, we don't continue. Yep, so this, I think this finds us all potential positions. Let's try this out. fim dot, for all positions, let's just print out all the possible positions that we have and run it on the test case. We don't call this function yet. I was just about to, anticlimactic, it doesn't work. The sea monsters in the map. So we find 3 possible sightings. One is in, let me, full screen this. Oh, it doesn't matter whether I full screen this on it. So I can't, I realized at some point that you can't necessarily see the lower bottom half of my screen, lower bottom right of my screen, but I hope that's fine. So the first sighting is at 3.2, and let's just look at this. So this is the map. Let's look at row 3, 0, 1, 2, 3, map 2. So it says position 2. So it says that there might be a sea monster here, which is a hash, then 4 somethings. So hash 4 somethings, 2 hashes. So hash 4 somethings, 2 hashes, 4 somethings, 2 hashes, 4 somethings, 3 hashes. Yes, there's a sea monster there. Cool. Of course, it doesn't verify that like it finds all, but whatever. And 17 and 21. So we have, how many rows is this? (24). So row 21 will be, so this is 23, 22, 21, position 0. Hash 4 somethings, 2 hashes, 4 somethings, 2 hashes, 4 hashes and 3 something. Yeah, so this actually, this does seem to do something. Okay, so we have possible sea monster sightings. Let's confirm these sea monster sightings. If sea monster 0 dot match string m dot tile pos 0, m dot tile pos 1 bis until for the record, I'm German, so I sometimes tend to revert back to German. P1 plus, how many is this? Yes, I'm that kind of lazy. 20. So so row P0, position P1 until P1 plus 20. Yeah, looks great. And this is going to be the same. Oh, no, this does not look great because this needs to be the row before and this needs to be the row after. Apart from that, everything is the same. And now this will be a confirmed sea monster sighting. So, confirmed sea monster sighting. Wait. Why does it print the map first? And oh, because this is printed to stdr. Better. Okay. So, okay, this didn't help even remotely as much as I hoped. Okay, so this is the map, and it says, oh, I found 2 confirmed ones. One is in like row 3, position 2, and one is in like row 17, and like we actually have them pointed out here. So this is row 3, position 2. Great. And one is in this one, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. But I started counting at 1. I should have counted from 0. So this is 17, position 1, I guess. Yes, we actually found our 2 sea monsters in our test input. And now what I want to do before we do anything else is I want to run this on the input and see whether anything overlaps. Because if nothing of them none of them overlaps, we are super golden. Oh my god, it runs forever. Correct orientation. Now it will find things. This takes a lot longer than I would have hoped, I have to say. Must be this garbage Go regular expression engine. I'm just kidding. It's actually a pretty great regular expression engine, but it's also not a great problem. Why does this take so long? Oh man. I mean, it's not that much text. It's just like 120 or something lines times 120 or so things, and all of them are hashes or dots. Oh. I mean, we could try to speed this up. Like, we could try to look for the longest substring of hashes that is in the C. No, because we... And like only restrict ourselves to those. But like the regular expression engine should already be pretty well optimized. Like we shouldn't really be able to outperform them. Is this maybe an endless loop? But why would it be an endless loop? Is there a reason for this to be an endless loop? Let's check if this might be an endless loop. Find CMOS. So this runs fine because we found the correct orientation. So this must be the problem. So this theoretically, if this doesn't, then it breaks. So this either breaks here or J increases, right? Like, so either we abort the loop altogether or we break, or we increase J. Do we necessarily increase J? J equals log 0 plus 1. Log 0 will always be... Oh, yes, this might be an endless loop. Oops. Yep, because we actually started looking at J. So this also means that we probably have overlapping sea monsters. Yep. Okay. this is a lot faster. Yeah. Turns out if you write an endless, so the issue is like J is an index in the entire row, but log is an index in everything from J on. So log like if we use log as an index into the this should also thus be plus J. If we use log as an index into the entire string, we need to increase it by J because we only started looking at J. Yeah, so now we have 4 sea monsters, and like they are disjunct, right? They are not, right? I'm not dumb, right? They look very disjunct. Like the difference is always like more than 3 lines between them. So we can actually just count the hashes in the entire thing and just count sea monsters and hope that they are all disjunct. And in this case, they will be. So let's do this, I guess. Right? This should be easy. Oh, I'm sitting in front of the sea monster locations. Yeah, you're right. I'm sorry. Wait, let me, this is not what I wanted to move. here, you don't need to see the code, right? I don't know. There's no good position for me. I might have to come up with something for that. But yeah, okay. So now you can see the sea monster rotation. Yeah. Yeah, but like you can see now, these are the locations we found, and you can see that they don't overlap. So I will now do the very, 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 very lazy thing. I will do not the very, very, very lazy thing. Count sea monsters. Var post2 or var n int, we only need the count, n++, return n. We will just count the sea monsters and pretend that this actually does the thing. So, laziness wins. Func count hashes in a tile for all rows. Go doc strings. It's fine, scrolling up 10 lines was enough. Yeah, I know. But like, I would like to have a more structural solution to this because it happens all the time and I tend to forget. So there's probably a count. Yeah, count substring. Yeah, this seems like what we want, right? N plus equal strings dot count in the row the string hash. Return n. Great. Count sea monsters. Hashes is count hashes in M, and now fm.printf number of non-sea monster hashes will be the number of hashes minus the number of sea monsters times how many hashes in a sea monster. Sentences I didn't expect to say in my life. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15. Let's hope that this is right. Times 15. Let's first try the test case to see whether we are correct. 273 is the output. 273 is the output. So let's do it on the input. 2093. That's not the right answer. My answer is too high. My answer is too high. My answer being too high means I have not found enough sea monsters, I guess. Right? Or I miscounted the number of hashes in a sea monster. 1, 1, 2, 3, 4, 5, 8, 9, 1, 2, 3, 4, 5, 6, 15. Nope. works on the test case. It doesn't seem to work on our input. Let me verify some things. So let's first copy all of this into a map. Yep. So is it cut? Remove sections. No. Does tr do that? Delete. Cool. Okay, 2, 1, 3, whatever. And we remove 60 from that and we get 2093. So yeah, it does seem that if we manually go through that, we do get the same result. How rough the waters are in the sea monster's habitat by counting the number of hashes that are not part of the sea monster. In the above example, the habitat's water roughness is whatever. But like, I mean, the thing is, like, even if I now mark out the sea monsters and everything, like, that doesn't change the fact that like, we apparently didn't find enough sea monsters, and like, if we didn't find them, replacing them also doesn't change the thing. But like, why, how could we not find all sea monsters is my question, basically. Someone help me understand what's going wrong. Oh, I actually have to go soon. Damn, I was hoping this would work. Okay, so we start at 0, we go until it's less than this. We look for this thing. m.tile I is the row we are currently looking at. How did the map sea monster orientation thing work? So can you be more specific? Like, this is the code to, this is basically the code to see, is there a sea monster somewhere? And this really just looks at the map and checks, is there a sea monster anywhere? Right? And then we, oops. And this seems fine. Like, we look for a sea monster in the ith row, like for the middle row, from 1 to m.tile -1. Then we say, if we can't find one, we continue. If we can't find one, we look for row I -1 in the same location. And if not, we continue because it's not a sea monster. And if so, we look in the row below that in the same location. And then we return true if we found a sea monster. So this looks super simple, right? Can there be sea monsters swimming vertically and horizontally? So this is something I'm not sure about. When looking for this pattern, the spaces can be anything. Because the image is monochrome, a sea monster, like, so I would have kind of assumed if that is the case, they would emphasize that or like show it in the example, right? But when looking for this pattern in the image, the spaces can be anything. Only the hashes need to match. Also, you might need to rotate or flip your image before it's oriented correctly to find sea monsters. In the above image, after flipping and rotating it to the appropriate orientation, there are two sea monsters. Like, this makes it sound like there is one appropriate orientation. No, like, it's not or some swim left to right, some right to left. Like, technically this can be the case, but like, let's see. Let's like, I would have expected them to emphasize that, but I was confused about that. Let's say we return multiple orientations, one for each that has sea monsters, and now we will just check all of them. And then, given that we look through all orientations and all flippedness of the map, like, if there is any sea monster anywhere, we should find it this way. Oh, we flip upside down, we don't flip left to right. No, it's not even, we will not even find, yeah, we will not necessarily find flipped sea monsters. Wait, let me look at the thing. When looking for the space can be anything. Know your research. Because your image is monochrome, a sea monster will look like this. Like, there's yeah, well, I mean, like, the thing is, the description, like, so the example only contains the very vanilla sea monsters, and the description, like, does not contain a sentence like, you keep in mind that the sea monster might be rotated or flipped or whatever, right? It just says you have to rotate the map to find, like, to the appropriate orientation such that you can find the like, look for sea monsters. Which is, like, technically it doesn't exclude it, but like, if that's the case, it's not super, like, obvious from the task description that it can be, right? Time again. No new variables, fine. Yeah, I mean, yeah, kind of. So we have looked through all the maps and we haven't found any, right? Like, all map orientations. And so, like, if more than one map orientation would have any sea monsters, this would have complained. Technically speaking, if the sea monster is just swimming in the wrong direction, we won't find it this way, because we flip upside down and not left to right. And then also, like, yeah, we also need to look for, like, mirrored sea monsters. So let's add a mirror monster just to be sure. Luckily, I have this helper. Now we will also look for mirror monsters. And I guess it still doesn't find all of them, but, like, at this point, now it says more than one orientation has sea monsters. Yeah, but I mean, to be honest, I don't, like, Yeah, so I guess it might be that they are actually arguing that this is what you have to do, but um, yeah. So now the problem becomes that, like, especially like if they, like, how can they all, like, what are all the valid orientations? Like, can they be flipped upside down? Can they be only be flipped like left to right? And like, do I have to look for like all the, and then like what's with overlaps, and like the problem becomes so freaking underspecified at that point, right? Anyway, I think I will either way have to break now. Like I have to stop now. I'm not like I'm not convinced that this is what's meant, because like it just seems like if that was meant, they would have emphasized that, like either by showing it in the example or by writing it out. Like they don't they tend to not be that obscure. And like it's not as simple as saying like, because like for example, like it's not as simple as saying you look through all orientations of the map, right? Because you flip it, I guess. Oh no, that would be fine. Yeah, so I guess mirror monster, I would kind of believe mirror monster. um I don't know. I will think about it, and like I don't know. I will for now leave it at this, because I have another thing in like 5 minutes, 7 minutes. So I will think about it, and maybe I will Google what other people think about it, because like I don't know. I have to say I would be pretty pissed at this point, but yeah, I can. I guess what I will do is I will check for one flip, like going into the other direction. Because that is something that is not currently caught. And then I will kind of not do the more than one orientation as sea monsters, but like we'll just choose one of them and see how many flipped versions there are and where they are. But I can't do that right now because I'm out of time. But like I'm also, the code that I have seems to do what they want. Like seems to do how I understand the problem pretty much correctly. Like I really don't understand what I'm doing wrong, if apart from maybe misunderstanding the problem. I don't know, because like they are super disjunct. Wait, now it doesn't find any sea monsters anymore. Oh yeah, because and like they definitely don't intersect at any point. They are in very different rows, and there are only 4 of them, and the number of them is fine. I don't get it. I don't know. We will see. I will see what I do about this. I feel like I've done this thing correctly, but whatever. Anyway, thanks for joining, and thanks for helping and talking and interacting, and maybe I will see you tomorrow. Yeah, I don't know. I just the rest of the problems just isn't as confusing as this. I don't know. But I don't know. I don't know is the correct answer. I know someone who did actually solve both parts, and I might just ask them what they did, like what they searched for. Anyway, for now I have to run. See you maybe tomorrow. See you another time. We will see. And